Okay, we're going to look at another definite integral here, where we're going to sketch the region represented by this definite integral and use geometry to find the value of this integral. All right, so similar to the last video, we want to think about the function graph, what that looks like. So we're looking at, this time, the function y equals the negative square root of 49 minus x squared. So similar to the last video, we might recognize what this is without doing some algebra. I'm going to go ahead and do the algebra, but the more of these you do, the more likely you are to recognize what this graph looks like and be able to sketch that without needing to write out some steps. If I want to do some algebra, though, I can square both sides here. I need to square both entire sides, including the minus sign on the right side of the equation. So I'll have y squared equals, when I square the negative, that will make that positive, and the square will undo the square root. So I'll just be left with 49 minus x squared. Then if I add x squared to both sides, I'll get x squared plus y squared equals 49, which is a circle with radius 7. All right, so one important difference between this problem and the last problem we looked at, though, is that what I started with here was a slightly different version of the function equation. So what we started with, we had y equals the negative square root of 49 minus x squared. So this would be not the entire circle. The entire circle is not really a function, but this is going to be the part of that circle where the y values are less than or equal to 0, or negative or 0. So because of this negative out here, we really have the bottom half of that circle of radius 7 centered at the origin. Okay, so let's go ahead and sketch the picture here. So a circle with radius 7 centered at the origin, but we really are just going to have the bottom half of that circle. All right, so there is the curve that we're interested in. And we're interested in that curve on the interval from negative 7 to 7. So all the way from x equals negative 7 to x equals positive 7 over this entire interval here. So we're interested in this entire region here. All right, so sketch the region represented by this integral. That's what we have here. And this is our curve. That's the function y equals negative square root of 49 minus x squared. And I've shaded in this region from negative 7 to 7. Okay, and then use geometry to evaluate this integral. So I want to think about this again. Similar to the last video that we looked at, this is a part of a circle. And I know an area formula for a circle, a equals pi r squared, area formula for a circle. For this circle, since the radius is 7, I can write the area for this circle. So for this circle, we'll have pi times 7 squared, or 49 pi for the whole circle. We actually have only a half of a circle. So half of that area would be 49 over 2 pi, or 49 pi over 2, area of a half a circle. But I need to be a little bit careful here and remember that this integral is really signed area. The definition of this as a Riemann sum is the sum of function outputs over this interval. Remember, we partitioned this interval up into little pieces. We took a point in each of those elements of the partition. We evaluated the function at that point, and we had all of those little rectangles. Took the limit as the norm of the partition approaches 0. But in this kind of picture, if I think about those rectangles here, the function outputs will be negative. So when I look at a picture like this, and I think about a definite integral like this, one of the important things to notice here is that this is going to be a negative value for that integral, because all of the function outputs everywhere along that curve are negative. So when I think about that Riemann sum, the function outputs, this part, is always going to be negative. So when I think about this integral, I'm going to get a negative value. All right, so geometry helps me find area of a circle and then a half circle. But then thinking about the Riemann sum definition is going to help me write the correct answer for this integral, which will be negative 49 pi over 2. Okay, so that's a little bit tricky, making sure that you think about the negative in there as well. All right, we'll look at some more videos.